So first and foremost, what do you think of the questions, the practice questions? Is it okay? Is it good? You guys can respond in the chat, inshallah. If you don't have to verbally respond to the question. So macam mana soalan-soalan praktis tu? Okay ke tak okay? Yang tengah buat sekarang.
It's okay, sir.
Alhamdulillah.
Yes. But for the Kirchhoff's laws, it's a bit, complicated. The second law one.
I see. Okay. So we'll try to approach it, inshallah, today. Tapi just a disclaimer, if you notice the practice questions here do not actually involve much on the Kirchhoff laws. It's more on the potential divider punya questions kan?
Yes.
Yeah, you can expect on Monday the questions will be more on the Kirchhoff laws. Tapi kita try untuk explain lah sikit-sikit based on the potential divider punya circuit. Okay?
Okay, sir.
Alright, so let's proceed, inshallah. Question number 1, a DC power supply of EMF 12 volts has an internal resistance of 2.3 ohms. It is accidentally shorted out across its terminals by a short length of wire of negligible resistance. Okay, for this first question, can anyone draw me the diagram for this question? Can anyone? Are you guys up for it? Do you guys prefer a one-way punya lecture style discussion ke interactive discussion?
I don't know, sir.
don't know.
I'm not sure. Interactive, I think.
Okay, anyone? Well, I would like an interactive session lah. This would really help. Tapi kalau if you guys are not up for it, then it's okay, boleh je. Saya
I don't know. I think I will give it a shot. Yeah.
request for annotation, I'll approve it. Or you can just tap on the screen at any point.
And what?
You can just click on the screen.
Click on the screen?
Yeah, click on the slide that I'm sharing it. Then you'll be able to draw.
But I'm clicking.
Yeah. Tak ada dah? Tak ada lagi?
No. There's nothing.
Okay, that's weird. Okay, let me just try again. Okay, try clicking on it again. Tak ada lagi
Nothing, sir.
It seems you are being blocked from anything. I'm not sure why. Probably it's your settings. Anyhow, tak apa. Have you got any other takers?
Ame.
I'm asleep, right?
It's okay. Kita jalan dulu lah. Nanti along the way, not going to time on this question.
I see.
Okay. Pagi-pagi ni dia technical problems. So this is the circuit that we are talking about. Okay.
Oh, okay.
Oh.
Simple je. Yang daripada notes kita kan. So kalau if you see here, the EMF is actually a component that consists of the source, the potential difference source, which is E, as well as an internal resistance. So the dotted lines or the dotted box, this region is actually representing the overall EMF. So the overall EMF has got 12 volts. Okay.
Okay.
So dia kata internal resistance of 2.3 ohms. So the small r is going to be 2.3 ohms. And then it says it is accidentally shorted out across its terminals. So where are the terminals? The terminals are here. This is the positive terminal of the EMF, and this is the negative terminal of the EMF. So when it says that it is accidentally shorted out, so what does it mean? It means that even though, for example, we have an external resistor connected to it initially, but since it says it is being shorted out, maknanya dia short circuit lah kan. Kalau you recall last week punya yang bonus slide tu, saya ada mention tentang short circuit kan. So short circuit maknanya there is a wire connecting to this. So instead of the current going through the loop that contains the resistor, it actually goes to the loop without any resistance at all. So kat situ, in that situation, dia akan short circuit. Okay. Alright. So calculate the current drawn from the supply. So because this is an EMF that contains an internal resistance, current will be able to flow. Okay, kalau dia normal punya potential difference punya battery supply, yang tu current will not flow lah because dia distance kan. Cuma dalam case EMF ni, there will be flow of current yang kita boleh calculate because of the existence of internal resistors. Okay, so how do you calculate this? It's basically a single loop where you have a source, 12 volts, and then you've got the resistance at 2.3 ohms. And then you calculate using the formula I equals to E over R, okay? Which is the V equals to IR equation lah kan. Cuma it does not go through the R, the external R, since R is the power supply. Since R is the power supply, sorry, dia ada problem sikit dekat increment tu. Sepertinya since R is short circuit, then R equals to 0 ohms. So I is equal to 5.2 amperes. Okay. So at any point, if you have any questions, please ask straight away. Kalau macam tak faham ke apa-apa, just jawab je lah kat situ. Right. So this is single loop. Kalau kita tak main dengan Kirchhoff law kan, kita ada dua law kan. We've got the Kirchhoff first law, which is concerning the current, if I'm not mistaken. Betul
Yeah,
tak?
yes.
We've got Kirchhoff second law, which is the voltages. So kalau kita tengok originally, if you play around with the Kirchhoff laws, it's quite straightforward sebenarnya. The voltage supply E here is this one, betul tak? Kita ada E kat sini. And then a potential difference at each component of an electronic component kat sini. Okay, which is consists of E kat sini. So kalau kat sini dia akan jadi positif kat sini, negatif kat sini, positif kat sini, negatif kat sini lah. Okay, so we will have the same current flowing through each of the resistor or each of the component connected in one loop. So what does Kirchhoff law state? Kirchhoff second law state. Dia nak kata total voltage supply ataupun total voltage in within a loop will be equals to
0
plus V small r in this case, ataupun misalnya dia akan kata V1 V2 kan. V1 V2. So this is overall Kirchhoff law, Kirchhoff second law yang dia nak cakap. So kalau kita ada complicated circuit ataupun large circuit yang ada branches and everything, so playing around the loop lah, yang itu yang mungkin confusing kan. Cuma the basic ialah conservation of energy. All of the voltages supply will be equals to all of the total voltage that is being output. So the input will be equals to the output. So always remember that. Okay. Alright. Question B. Suggest why it may be dangerous to have a supply shorted out in this way. So ni hazard ataupun kita panggil kalau ialah short circuit ke apa-apa kan, problem dia probably ialah heat lah kan, sebab dia akan terbakar. So excessive heating of the power supply, that would be dangerous ataupun hazard lah in the case of having a short circuited punya power supply. Okay. Alright, question number 2. A cell of EMF 1.5 volts is connected across a length of wire of resistance 2.6 ohms. A high resistance voltmeter placed across the terminals of the cell measures 0.85 volts. Okay. So, does anyone want to draw the circuit for this one? You can request for annotation. Okay, Ami, go.
Alright.
Hehehehe.
Right. Mm. I know what you.
Yes, you have a length of wire. Is that it? Okay.
I can draw a dot.
Yeah, you can just click one click in. Okay. Is that it? Is that it?
I think so.
Okay, thank you very much for your attempt. A round of applause to Ami. Alhamdulillah, thank you very much. So he drew a cell of EMF, dia kata 1.5 volts. You can label the where is the 1.5 volts, Ami? Where is the difference between 1.5 and 0.85? So dia ada dua yang beza kan?
Yeah.
We got here 0.85, the other one is 1.5 volts.
0.5, 1.5. So the difference will be.
So it is a beautiful drawing. It's a good effort, especially when you had to draw using ni kan.
Oh no.
85 pula.
0.65.
0.65. Oh, so you calculated it straight away.
Yeah.
This is interesting. So anyone wants to comment on this?
Isn't the potential difference supposed to be the same, sir?
Yes. Suppose.
Yeah.
Okay. It's all right. It's okay. Thank you very much. So an improvement that we could see in this. Who was it just now who commented on it? I think it's Fatiha, betul?
Yes.
Okay. Can you improve on the on Ami's drawing?
I'm using the phone, sir, so I think it's going to be a little bit messy.
Unity. One way you will improve, because this is an EMF. This is an EMF. Usually an EMF consists of the original cell. Dia punya apa kita panggil dia punya supply lah. So just sorry. The drawing is wonderful, Ami. I just had to.
No, it's hard
Rip
to
Ahmed's
draw
drawing.
using it. It's hard to draw using mouse.
Okay, so you should add an internal resistor kat sini.
Okay.
Boleh ke? Tapi bila you put a voltmeter across the EMF, this is the EMF if you put a voltmeter, dia kata high resistance high resistance voltmeter lah kan. Kenapa dia sebut high resistance? Anyone siapa boleh tahu kenapa dia letak perkataan high resistance kat situ?
Oh, to prevent short circuit.
Along Syirhan macam nak dapat dah tu. Dia letak high resistance untuk nak kata the internal resistance of the voltmeter can be negligible. So that means no current is actually flowing through the voltmeter. Sebab kalau ada voltmeter, dia akan affect the value sebab dia based on Kirchhoff first law. Okay, Kirchhoff first law dia cakap apa? Kalau Kirchhoff first law,
current in equals to current out.
kalau ada current yang masuk ke dalam sini, so current yang keluar dekat
The other side.
kita ada I V, and then kita ada I EMF, and then kita ada IC. So kalau ikutkan, in an ideal situation, IE would be equal to IC. Ideal situation yang mana apa? IV itu sama dengan kosong. Kenapa IV itu sama dengan kosong? Because high resistance. So kalau a comparison between high resistance voltmeter and the internal resistance of the EMF as well as the resistance of the wire itself, kalau dia too big, the resistance is too large, that means no current. Atau kita boleh assume the current flowing into the voltmeter is almost equals to zero. So all of the current generated from the EMF will be flowing into the circuit, into the length of wire kat situ. Okay, sebab tu dia guna term high resistance kat situ. Because of Kirchhoff law. Dan Kirchhoff law kata apa? Total current going into a node or a branch will be equal to the total current going outside of the node or the branch. So kalau kat sini, where is the node? The node is here. Macam Amir kata lah, susah nak lukis dot kan. Tapi ada node lah kat situ junction lah, junction kat situ. Okay, junction maknanya current keluar, dia akan masuk dekat T junction tu. So sepatutnya ada current yang pergi kat voltmeter, terus ada current yang pergi dekat length of wire tu. Tapi sebabkan high resistance voltmeter tu, so IV tu is negligible. So we can safely assume that because we are using a high resistance voltmeter, all of the current generated from the EMF is actually converted into the circuit punya current. Okay, so tu general knowledge lah sikit-sikit lah kita masuk Kirchhoff first law, Kirchhoff second law macam tu. Alright?
Sir,
Yes.
if the voltmeter still show leaving even though it's not moving at the junction.
Yeah, sorry. Yes, dia akan juga. Okay. Okay, next. Okay, so now we are commenting on the question lah kan. So we have an internal resistor here, and then we've got this the potential difference here. So bila dia cakap 1.5 volts kat sini, it is actually referring to what?
The actual
voltage.
Ini kan?
Yeah.
Yes.
Kat sini sepatutnya. So based on Kirchhoff voltage law, kat sini dia guna apa term Kirchhoff first law, Kirchhoff second law kan. Tapi ada juga in electrical engineering dia senang je, dia sebab susah nak ingat first law apa, second law apa kan. So dia panggil KVL dengan KCL, Kirchhoff voltage law dengan Kirchhoff current law. So dia sebut Kirchhoff voltage law, which is the second law. Dia kata the total number of voltages around a closed loop will be equals to zero. Maksud dia apa? The total supply must be equal to the
Total output.
voltage output kan. So 1.5 volts is the supply. So 1.5 volts will be distributed across the length of wire V kat situ, as well as the internal resistance kat situ. Okay, so sebab itulah bila dia letak voltmeter across the EMF, the reading is only 0.85 and not 1.5. Sebab apa? Sebab ada voltage yang dimakan, kita panggil voltage loss lah kan. Ada voltage loss because of the internal resistance of the EMF itself. Okay, which is actually the first question lah. Okay, thank you very much Amir and Fatihah for the contribution. So kita proceed dulu. So calculate, this is the same circuit. Alright, part A. Calculate the potential difference across the internal resistance that is located within the EMF ataupun next to the supply yang kita tengok dekat graph, circuit yang ada kat atas tu lah. So how do you calculate this? It does not involve any equation, tapi lebih kepada understanding of the Kirchhoff voltage law, which is Kirchhoff second law. The total number of voltages across a closed loop will be equal to 0. In this case, source is equals to output. Total input is equals to total output. So kat sini kita nak tengok VR, V small r, which is the internal resistance lah. We substitute, so the value is 0.65 So I mean, you have to look back at your equation. 0.65 tu dekat mana sebenarnya? It is not the voltage across the wire, but instead it is the voltage across the internal resistance of the EMF. Okay. Then calculate the internal resistance of the cell. The current generated from the wire flowing in and out of the EMF. Okay, welcome class rep. So I is equal to VR over R, which is equal to 0.327 amperes. So kalau kita ada current kat sini, this current, dia flow into the resistor here, and then dia flow into the internal resistor here. So are they going to be the same value ataupun dia sum?
Same.
Value kan? Because what? Why are they the same value?
Kirchhoff's first law.
Kirchhoff's law, betul. Ataupun dalam bahasa mudah kita, because they are in series kan, resistors they are placed in series. So bila masuk, dia keluar sama lah kan. Ataupun sebenarnya first law tu memang cakap lah, dia, if you assume that R is a node, so the current going inside is equal to the current going outside. Tapi kalau dia parallel kat sini, sebab itulah current going inside is equals to the branches kat sini. Kalau dia ada dua lah kan. Okay. Okay, good morning Naufal, it's okay. Bulan puasa kan. Bangun pagi, tahajud, Masya Allah. Lepas tu sahur kan. Lepas tu subuh tertidur biasa tu. Okay. Alright. As long you are here, then it's okay. Alhamdulillah. So how do you calculate the current? Well, we can actually use, kenapa kita guna VR here equals to 0.85 volts? Because 0.85 volts is actually supplied to the resistor kat sini. Okay, it's not 1.5. Kalau kita nak guna 1.5 macam mana? Kalau kita nak guna potential difference tu 1.5, maknanya what is the value of the resistance?
The internal one.
The internal one. Is it the internal one only?
Plus external.
The resistor.
Yes. Sebab kalau kita nak guna current is the same throughout the circuit kan. So kalau kita nak guna I equals to E over resistance, cuma resistance dia is not going to be just the internal resistance. It must be added to the external resistance as well. Because this is the original source kan. So kalau kita consider macam ni, voltage dia, so dia akan supply dekat both the external resistance as well as the internal resistance kat sini kan. Sebab dia seolah-olah external resistance dengan internal resistance tu dia connected in series. So kita tambah jadi satu resistor saja kan. So the entire E will be supplied to the R plus R kat situ. Tapi kat sini kita just guna VR. Sebab apa? Because we do not know the value of the internal resistance. Kan? Sebab dia tak bagi tahu lagi kan. Which is the value of the resistance value of the internal resistor ialah benda yang kita kena cari. Kita tak provided with that information. So we have to work backwards lah. Alternatively, we can use I equals to VR over R kat sini lah, because we are given VR kat sini. 0.85 because that is the voltage supplied to R. Kalau tak nak guna 0.85, boleh je guna 0.65 divided by the value of the internal resistance. Cuma kita tak tahulah sebab benda tu yang kita nak tahu. Okay. So the internal resistance of the cell, we can use V equals to IR. So the answer is going to be 2 ohms. Okay. Any questions?
No.
Okay. I am open to any question kalau you guys nak tanya bila-bila. Sebab ada juga di kalangan you all yang memang tanya. Even in odd hours pun saya akan layan je soalan tu. Pukul 9, pukul 11, tengah malam pun boleh. Ada masalah. Memang semalam ada orang tanya pukul 11. Tapi ada juga yang tanya pukul 9 tapi saya terpaksa jawab pukul 11 juga. So saya ada meeting, saya ada usrah apa semua tu kan. So I'm very sorry kalau saya lambat respon. Cuma yes, I will make a point of actually responding ni lah. It's either lambat ataupun cepat lah. Okay. Any questions pun sangat-sangat dialukan walaupun berkaitan dengan Game Boy. Yes, Amir.
If I can also use the equation I equals to E over R plus R, right?
Yes.
Right.
Sorry?
Then equals to EMF over internal resistance plus R, dr. Meaning,
Yeah, okay.
meaning the value I got from the first B, I substitute it into the B equation.
Okay. Yes, yeah. Okay. You can try it. That means kita nak check kan jawapan kita betul ke tak kan. So sepatutnya I itu sama dengan 0.327 approximately. Kita substitute R, small r yang kita dapat ialah 2 ohms. Large R ialah 2.6 ohms. So you add up 2 plus 0.65, you get 2 plus 2.6. So you'll get 4.6 ohms. 4.6 multiplied by 0.327. You should get the same value which is 1.5 volts approximately. Dapat tak? Okay. So that is actually a simple circuit lah sebenarnya. EMF ni dia sebenarnya simple circuit je. Dia macam ada satu source dan dia ada 2 resistor. Tapi nama satu nama R1 tu resistor ialah external resistor. Lepas tu R2 sama dengan internal resistor tu je. Tapi dia punya konsep dia tu semua sama je. It's actually a simple resistors in series punya circuit. Cuma je lah term tu lah yang pening sikit. Soalan dia tanya kan. Tiba-tiba dia internal resistor lah, potential difference kalau internal resistor lah. So dia main-main dengan term. So conceptually you have to be strong lah. Walaupun sebenarnya dia simple circuit je kan kalau kita tengok kan. Satu source dengan 2 resistor in series. So tak ada pelik-pelik. Okay. Alright. So let's move on. Question 3. The diagram shows a potential divider circuit. Okay, this is a potential divider. The battery has negligible internal resistance. So bila dia kata negligible internal resistance ni, dia macam potential difference sajalah kan, PD sajalah kan. Selalunya EMF dia akan ada internal resistance lah because dia convertkan energy lain kepada electrical energy kan. So the question is asking calculate the potential difference across Arif pun overslept. Dia tidur sama-sama dengan ni ke? Naufal. Calculate the potential difference across the 6 ohm resistor. So here we have a question yang dia cerita pasal potential divider. So we need to understand what is a potential divider circuit lah So potential divider circuit is when we have a voltage source connected to more than one resistor. Okay, itu saja. More than one resistor kat sini. So, kalau dia ada satu saja resistor, kalau dia ada satu saja resistor, dia tak akan dividekan potential tu. All of the potential from the cell will be provided into the single resistor. Tapi because dia ada 2 resistor, so dia akan distribute the original potential supply into their respective into their respective ratios lah. Sebab tu kita potential divider punya formula kan. So kat situ. So in order to attempt to answer this question, what we do is we need to understand the question first lah. Okay, alright, sekejap. Mengantuk nak tidur mana? Okay. So now we have, we can actually determine when we have two different resistors, we can determine the voltages across the 6 ohm resistor as well as the voltage across the 18 ohms resistor. Kan? So based on KVL, Kirchhoff voltage law, Kirchhoff second law, the supply voltage 5 volts must be equal to the output, where there are two outputs kat sini lah, V6 and V18. So what is the first step we have to do? We have to determine the current. Okay. So the overall current flowing in the circuit, so kalau kita nak determine kan, maknanya kita kena simplify the resistor lah kan. So resistor kat sini dia ada dua in series, so we can just add them up together and then we'll get the current approximately 5/24 amperes. So this is the, macam orang kata apa ya, pendekatan menjawab soalan potential divider manual way. Maknanya dia buat step by step lah. Sebab kita boleh je terus guna potential divider punya formula, but I would like to explain the mathematics behind the potential divider punya formula tu. Okay? Budak 6 bulan belajar physics. Alright. So current kita boleh dapat, and from the current, thus the current flowing into our 6 ohms in series would generate a potential difference of V equals IR kan? So we'll get the answer approximately 1.3 volts. So this current yang tadi kita evaluate tadi 5/24, the value of the current will be equal to the current flowing both into the 6 ohm resistor as well as the 18 ohm resistor. Cumanya voltage dia akan berbeza lah kan, walaupun current sama kan. So which resistor will have a higher voltage?
18 ohm.
18 ohm kan? Sebab the higher the resistance, the higher the voltage, because V equals to IR. I is constant kat sini because those two resistors are in series. Alright. So any questions regarding this first potential divider circuit? So the answer is 1.3. So can you answer it using this equation, this way, this method? So dia macam kita panggil lalu jalan yang agak jauh sikit lah. Although you can actually just skip and straight away using the potential divider formula. So what is the potential divider formula? V6 is equals to the resistance that we are considering, divide by the sum of all resistors, and then you multiply it by the value of the V in kan. Sepatutnya dia V out dengan V in kan. So V in is 5 volts kat situ. And this only applies for resistors in series kan. Kalau resistors in parallel dia terbalik kan. So the answer, you substitute the values, so you get 1.3 volts jugalah. Cumanya dia 3 step punya calculation saja kan. Kalau yang the previous method, kita kena cari current dulu, lepas tu guna current, dia multiply dengan dia punya resistance. So dia panjang sikit lah cara dia. Cumanya sebenarnya the derivation of this formula, the potential divider formula, sebenarnya originate from the manual yang kita buat sebelum ni. Okay, are you guys clear with this? Semua orang? Good? Kalau good, bagi thumbs up. How you want to give thumbs up? I don't know. Okay. So it's actually 10 o'clock already, kan? So dia tak ada 5 bahasa. So macam mana kita? Kita habiskan ke? Ataupun kita habiskan kat sini ke? Ataupun you nak proceed ke? Ataupun you boleh ni? I really don't mind. So kalau nak berhenti rehat pun boleh. Kalau nak proceed pun boleh juga. I give you 2 minutes to decide. Hello. Okay, macam ni. Kita akan proceed juga until question number 8. Tapi kalau siapa-siapa yang perlu untuk nak leave, then he or she is most welcome to do so and you won't be judged. Okay? Sebab yelah kita pun start lewat. Alright, is that okay for you guys?
Okay.
But we have class at,
Sorry?
I think we have class at 10:40.
Kan? This should be your break kan? Betul tak? 10 to 10:30.
Yeah.
So macam mana? Is this good enough already?
No, I guess continue.
Okay. Kita just continue sikit, tapi just lecture. Kalau ada apa soalan, nanti boleh tanya. Okay. Kita speed up sikit lah. So question 4 is almost similar to question 2. The length of wire of resistance 0.3 ohm is connected across the terminals of a cell 1.4 volts. A high resistance voltmeter measures a potential difference of 0.81 volts across the terminals of the cell. So calculate the lost volts. So kat sini this question dia gunakan term the lost volts lah, which is actually the voltage that is supplied unintentionally to the internal resistance of the EMF. Okay, so dia sebenarnya affect the efficiency of the EMF lah sebenarnya. So similar, kita buat VR equals to E minus VR, so you get the value of the potential difference is 0.59 volts. Okay, question B, dia suruh cari apa? Current generate, nak cari the value of the internal resistance. The value of the internal resistance, so the current generated from the wire flowing in and out of the EMF. Sama juga kita guna the voltage across the external resistor 0.81 volts. So the internal resistance will be 5.3 ohms. So ada additional question kat sini. Additional question kat sini ialah the ratio of the power dissipated in 7.3 ohms wire and the total power dissipated by the cell. So kalau yang P ni kita gunakan formula saja, P equals to I squared R. So you get the ratio of 0.58. Maksud dia apa kat sini? Maksud dia 58% only that's the power from the cell is supplied into the wire. Okay, maknanya ada berapa persen loss because of the internal resistor? 42% lah
42.
So 58% lah. So 58 ni dia macam apa? Dapat C Okay, question number 5. Two cells are connected in series. Each cell has EMF 14 volts, internal resistance 0.38. Combination of the cells is connected across an external circuit of resistance 1.8 ohms. So sebenarnya bagi saya lah, this question is straightforward. Cumanya nak understand dia punya bahasa tu lah. So calculate the potential difference across the external circuit. So how do you do that? Sama juga current flowing. Cumanya yang ni kita kena consider dia kena double kan. So kalau siapa yang buat Callan's mistake tu dia just guna 1.4 volts lah. But instead dia kena guna 2.8 volts. Sebab apa? Sebab dia kata kat sini ada two cells. Okay, dia ada two battery connected. So the current would be 1.094 amperes. The potential difference across the external circuit will be equals to 2 volts. Okay. So now the potential difference across the terminals of each cell. So in this question dia kata each cell maknanya each individual cell, bukannya both. So in this case potential difference across the terminals of each cell, kita guna VR equals to E minus VR. Cumanya kita tak guna EP kita tak guna the total E which is 2E, tapi instead kita just guna that individual cell. So we just use 1.4 volts, and for the internal resistance kita just guna R. Kita tak guna RT kat sini. Okay, so you get the value as 0.98 volts. Okay. Macam rushing pula. The diagram shows a potential divider circuit. The voltmeter has infinite resistance and the battery has negligible internal resistance. Question part A, calculate the voltmeter reading. So kat sini dia main dengan variable resistor. Okay. So maximum resistance is set at 200 ohms. Straightforward kan? So it's either we use the potential divider circuit formula ataupun kita kira manually macam tadi kan. Tapi yang ni kita tahu lah V out, which is the reading of the voltmeter, across the variable resistor which is set at 200 ohms. So the value would be 3.2 volts. But that is part A. What about part B? So part B, the resistance R of the variable resistor is gradually altered from its maximum resistance of 200 ohms to 0 ohms. So draw a sketch graph to show how the voltmeter reading changes with R. So in order to draw, we actually have to use the equation. Graph sketch of the change in voltmeter reading variable resistor from 200 to 0 from the potential divider formula. We use this one. This formula is actually the formula that we used previously in part A kan. Cumanya kat sini kita akan dapat relation RV over 180 plus RV kat sini. So it's going to be Y equals to X over 180 plus X times 6. So for that graph, nak kena visualize lah kan. So cara you visualize is either you play around with your graphic calculator ke, ataupun you plot it manually. That means you tabulate the data and then you plot it. So, but we know that as RV is decreased to 0, what happens to V out? So V out will be close to 0 as well. Dia akan jadi kosong juga kan. So kalau RV kita substitute kosong, kosong divide by 180 plus 0, which is going to be equal to 0 lah. So V out will be approaching 0 as well. So kat sini, this will be the graph. Okay. Kalau you nak buat terbalik, dia punya x-axis dia akan daripada 200 ke 0 lah. Cumanya kalau conventionally dalam Cartesian plane, it must be 0, 0 at the origin kan. So decrease in resistance will be from right to left. So dia akan curve kat sini sebab dia x over 180 plus x. Okay. Alright. Boleh ke?
So what is the equation of the graph, sir?
The equation of the graph is this one. So let me just clear it up. This is the equation of the graph. Okay. So this is the y-axis, VR. Okay. So VR is equal to RV here. RV is the x-axis. So you substitute the values of RV. RV, apa range of values of RV, kita boleh sebenarnya buat tabulate data kan. RV here, and then V out kat sini. So RV initially dia 200 kan. So you can use points, mungkin the spacing will be 10, tapi banyak lah kan. Because I did this in Excel, so senang je lah kan, copy paste semua keluar sekejap je generate kan. Cuma you guys bila nak buat dalam kertas tu mungkin lambat sikit lah kan. Macam mana you nak guna 20 ke 40, as long as you can see the curve then it's fine. Sebab dia tak specify, sebab dalam soalan ni pun dia kata draw a sketch kan. So it taklah kena guna graph paper ke apa kan, unless dia stated macam tu lah kan. So the initial value of the graph will be 3.2 volts. Tapi kita tahu kalau akhir value R dia punya voltage akan jadi kosong juga. Okay. Right. Moving on, question 7. Okay, yang ni dia guna thermistor. Tak perlu risau pasal electrical thermometer, negative temperature ni semua saja je dia punya pembayang nak buat macam ni engineering punya question lah kan. So dia kata at 30 degrees Celsius the thermistor has resistance of 2.4 kilo ohm and this decreases to 40 ohms at 100 ohm, 100 degrees Celsius. So they try untuk nak catch us off guard lah kan. Dia gunakan notation kat sini 2.4K. And this one is 430. Nampak macam, oh 2.4 macam sikit kan. But it's not kan. Dia sebenarnya, yang ni lah 2400. So dia higher resistance at lower temperature. At higher temperature dia akan jadi lebih rendah. So this is the minimum resistance. So dia kata, the battery has negligible internal resistance. Calculate the maximum input voltage into the data logger. So the data logger is actually connected not to the thermistor but to the external resistor at 3.6 kilo ohms. So kalau kita nak maximum input voltage into the data logger, maksud dia apa? The value of the resistance here must be minimum. Betul tak?
Yeah.
In order for us to have a maximum voltage dekat sini. So instead of using the 2.4K ohms, we use this resistance. Sorry, minta maaf semua.
Okay.
So you substitute the value of Rp, the resistance of the thermistor, at 430 ohms. Okay, so the answer is 4.5 volts. Okay, last question. Complete the table. Complete the table. So you are given EMF 1.5, internal resistance 0.5, connected across a variable resistor of resistance R. So yang ni sebenarnya sama dengan question number 4, question number 2 semua tu kan. So you just have to list down the equations and then you calculate lah manually kan. Tapi if you have access to a laptop, you just use Excel senang. Okay. So I equals to 1.5 divided by R plus 0.5. And then as for the V, yang ni confusing sikit. Tapi V is equals to 1.5 minus 0.5 times I. You try to figure this out. But these are the basic equations that we will use to fill in the table. So you can plug in the values and you get the answer guys. Okay. Cumanya question ni kenapa dia suruh kita cari manual I, V, P and whatnot tu? Sebab dia nak untuk question number B tu for our analysis part. Okay. Okay, question number B. With the aid of a sketch graph, describe how the power is dissipated by the external resistor is affected by its resistance. So, if you plot it out, you akan dapat macam ni kan? Dia punya curve. So, curve kat sini, dia akan ada maximum at 0.5 ohms. This is the maximum value, which you can actually observe from the data previously lah. Which kat sini, kalau kita tengok, at 0.5, where is the maximum power? Which is 1.13. So this is the one. Okay. And bila kita proceed kat sini, what is the significance of having this 0.5 ohms as the external resistance? Kalau kita tengok, the internal resistance value is actually 0.5 juga untuk nak dapatkan maximum power. So conclusion is, based on the data and sketch graph, maximum power is reached when R equals 0.5, i.e. this resistance value is equal to the internal resistance of the cell. So if we have an EMF and we want to have maximum power to the load, to the external load, what we have to do? We have to make sure that the resistance of the external load must be equal and matches the internal resistance of the supply. That's how you get maximum output. That's it.
Sir, that should be 1.3 watt, right, sir?
Yes, 1.13 watts, not volts. Thank you very much for pointing that out. Okay. So that's it. 8 questions. Sorry, I took extra time for your rest time. Hopefully, this discussion boleh memberi manfaat. I'll share the video once it is ready. If you have any questions, you can always ask whenever it is convenient for you, inshallah. Wallahu a'lam bisawab. So I guess that's it. Let me just stop this. Took us 50 minutes.